Cool. Hi, everyone, and thanks for coming to my session, the last one of the day. Well done for sticking through. Like most of the other sessions in this room, it's going to be kind of an architecture-based one. If you've been to either of those sessions before, some of it's going to be a little familiar, but we're going to take a look at some other new stuff as well. So I just wanted to give you a quick, brief overview of what we're going to cover today. So these 6 bullet points, essentially. So the first demo, the first theory is going to talk over how to identify bad code, and the downsides of poorly structured code, and conversely, the upsides of structuring it better. Then in the demos part 1, 2, and 3, we're going to respectively look at techniques to refactor your code safely, testing your code, particularly when it's code that isn't particularly easy to test in the first place, and then the last demo is going to be looking specifically at how to prevent mistakes from happening again in the future. So we'll first start with a quote. I thought it was a really good one initially, but now I've kind of realized it's not quite, it's a little bit tangential, but it's probably a pretty familiar quote to you. It says, "Those who cannot learn from history are doomed to repeat it." And this is what I see a lot of in my clients. Specifically, what I see a lot of times is people write a code base. It gets kind of worse and worse over, say, the period of 3 to 5 years, and then they end up having to just rewrite it all again, and they throw everything away. And then this will happen again. And this kind of cycle goes on of building code, it gets worse, they write it from scratch. And whilst this is a way to work, it's not ideal. And by looking at refactoring our code, we can try and prevent those big, grand rewrites from happening. So first, we're going to look at what bad code causes. Some of these are probably pretty familiar to you, especially if you've got code bases that are sort of in the 3 to 5 year range. I see this basically every day of my working career. So bad code quite often causes random bugs and crashes. If anyone's ever done a 100% rollout to the App Store and then found that some subset of users get a crash that's really critical and you have to roll out a bug fix really quickly, this is kind of probably an indication of some old code. And this happens more and more in older code bases. And it gets pretty hard to add a new feature. If you've got a massive view controller, you're just going to start to shove new features into it, and they get harder and harder as there's more stuff, there's more things that are kind of mixing with each other, and just more stuff going on. And people joining your team, if someone comes new to your team, they're not going to know all the decisions that you've made and all of the learnings that you've accumulated over, say, the last 2 or 3 years. So by making the code easier for them at the start, you're going to make them be a lot more productive on your code initially, and likely a lot more happier in the future. And if you were at Mike Katz's talk earlier about modularizing your app, basically if everything is one big blob, that's going to be harder to split apart than 5 smaller blobs. So when I'm talking about bad code, what do I mean? So obviously the archetype is a massive view controller. This is pretty much what the majority of bad code looks like on an iOS app. So obviously something like a view controller with, I've had one which has been 4,000 lines, which was quite a challenge. Yeah, so anything from 500 lines in a view controller is something that I would be really wary of. Code smells with cute little poop emoji. So code smells, if you've never heard the term, is a really useful way of working out where code is going wrong. These are kind of indicators of an underlying problem. We're not going to touch on many of them today, but I will give you some resources to find them out on your own time, because there's so many of them. Files which frequently change for completely different reasons are an indicator of bad code. So if I have a file that only changes because of one thing, that's kind of fine. But if it changes for many things, that's kind of an indication you've not split everything up that well. And also code with many branches. And also the kind of completion block pyramid of hell. That's also a pretty big indicator that maybe something's wrong here. So when we're refactoring a massive view controller, this is our big angry view controller, how are we going to do it this time? So refactoring is an iterative process. You can't do it like this. That was a really rubbish click. But you have to do it step by step. So what we would want to do is get to a good bit of code with a less worse bit of code. And then, once we've got into that state, we want to get, we'll get 2 good bits of code and then 1 bit of code that's OK. And this stuff on the right is going to be so much easier to maintain than stuff on the left. So when refactoring legacy code, what are the rules we're going to follow today? So we're going to want to get to the quickest point that we can start testing. Because without tests, we don't know if we're breaking something, basically. We want to avoid change in behavior in this time, because, again, we don't have any tests. So we won't know if we break it. We're going to commit frequently and build frequently. We won't be committing during this tutorial, just because it's going to take us a while. And also, don't be scared to roll back in the case that something's gone wrong. Don't just blindly try and fix something. You can always just, if you're committing frequently, you can just revert everything, start again. And the first step today, we're going to be looking at refactoring using methods, because this is going to give us a good indication of some extra classes that we're basically missing, and then that gives us a really good indication of where we can pull our architecture in the future. So with that, we're going to head to demo 1. So if you head into the demo 1 starter project, which you can find in the same place as all of the other projects today. This is session number 9, called spring cli ... your app. And head into demo 1 and the starter and the Xcode project. Now, just as a preface, I've had a lot of issues with Xcode 9.2, so you may see me force quitting my Xcode at some points. Hopefully you don't have the same issues, but yes, good luck. So I'll run the app so you can kind of take a bit of a quick look at it, and you can kind of see what it does. So it's pretty basic. We have a counts view controller. I can add a new count. It's kind of like a to-do. Yep, so in the meantime, if you build and run the app and you can kind of have a look at it, we can add a count, which is kind of like a to-do, but I use this app because I don't want to buy coffee too much because it's kind of expensive. And so I try to use it to limit the amount of coffee I buy by every time I buy a coffee, I add it, and I'm not allowed more than 3 per week. It is a pretty basic app. Yeah, so I can add a new count. Oh, no, it's going to be one of these. So coffee. And then if I click it, it's going to increment it. And once it gets to 3, it's going to tell me I've done too many. I've had too much coffee and I've spent too much money, which I should be saving. Yep, and basically everything right now is in the counts view controller. It's not in the typical terms of a massive view controller. The file itself is only 200 lines. But it does have a lot of stuff going on in it, and that's what we kind of want to avoid. Obviously, giving you guys a 3,000-line view controller would probably be pretty harsh, especially at the end of the day. So we've just kind of made a small little demo. So the first thing we're going to want to do, we're going to be using an MVP pattern for this. Any questions about why I've chosen that? We'll save them for the end, because we'll come back to it. So now what we're going to first start to do is create a counts view. And this is going to be the view protocol, essentially, in our MVP. So if you just create a new file, which is a Swift file, and call it countsview.swift. Sorry, that was very quick. Cool. And then all we need in this is not a class, a protocol, which is of a class type, because we want to keep a weak reference to it later. And this is all you need in this file for now. We'll come back to it in a little bit, but that's all we need for now. So raise your hands if you've got that. Wow, so many hands. Great. Cool. So if you head back now to the counts view controller, we're going to make our view controller be our view in this case. So we're going to scroll all the way to line 51, where there is the class declaration, and we're going to make it implement the protocol of counts view. So yeah, sometimes you'll make your view controller be the controller or the presenter or whatever, but in this case, we're going to make it the view. And OK, so we've got that now. So our counts view controller is our view in our MVP pattern. If you head down to the bottom of the viewDidLoad method, there is this GetCounts method. And this loads the counts from persistency. I can't core data. So, I mean, it's kind of a bit weird right now that we've got the GetCounts, which is kind of some model action of loading some stuff. And then we've also got the result of it, which is kind of sort of some presentory logic. And then also it's doing some view stuff as well. So this is an indication of what we're going to remove. So just below the end of viewDidLoad, we're going to create a function. And for now, we're just going to call it onCountsUpdated with a unnamed first parameter, which is an array of count. So this is essentially the counterpoint of when I load some counts and I call the getCounts method, this is what's going to happen on the way back. This is kind of the action from the response. And in this, we're going to do adapter.update with counts and table view.reload data. And you can see this looks exactly like we have in our completion block, and that is what we want, essentially, except for the weak self. So what we can do now is we can get rid of this completion block, and we want to call onCountsUpdated in its place. So we've at least now pulled out the kind of logic, logic is 2 lines long, but we've pulled out the logic of what we respond to when we get counts. And this is going to form part of our view protocol. So I want you to copy the signature of this function. So that's not including the curly brace on the top of the line. That is not what I meant to do. Copy it, and we're going to paste it into the counts view protocol. So just head now back to the counts view Swift and paste it there. So we're now making this part of our protocol. The reason we've made the view controller implement the protocol first is that now we don't have any point where we're not compiling right now. So when refactoring, it's hard to do, but the more time you're compiling, kind of the better, because whilst you're compiling, you can't run your tests, and whilst you can't run your tests, you don't know if something's broken. So if you're being a really strict refactoring, which I really encourage you to do in the case of a really big view controller, just try and minimize the amount of time you're not compiling. So we will head now back to the counts view controller. And we will do the same kind of method, this on something happened kind of function in the table view did select row, where we have the increment. So just below that one, do a function of on count incremented. We're being creative with our names, but this is kind of intentional. We want to make the names kind of consistent. So it's an update, and this is the type incremental update. We'll take a look at the incremental update struct a bit later. So for now, just don't worry about it. And we're going to kind of duplicate what we've got in these 2 lines again. So adapter.update with update.counts. And table view.reload rows at update.updated indexes with the animation.automatic. As index paths, sorry. So reload rows at update.updated indexes.as index paths. And then, has everyone got that? Hands up if you got it. Awesome. Then we need to do the same thing again for this AddCount view. And then, so this time I've inserted. You can see the method's called insert, so we're going to call the method onInserted. This is useful in the case that you're kind of not sure what a method's going to be called. If it's an action, call it onActionHappened. So this is going to be func onCountInserted. Again, unnamed parameter, update, which is of type incremental update. Then this time, I'm actually just going to copy and paste. No, I won't. Ignore that. OK, adapter.update with update.counts. The autocomplete is working today. I'm kind of impressed. And insert rows at this one. Yeah. Again, insert rows at update.updatedindexes.asIndexPaths with animation.automatic. So now's probably a good time to build. We should be compiling because we haven't really changed anything right now. Great. We're going to move these two declarations again into the view. So the onCount incremented, just copy that one. Again, avoiding the curly brace, and put it into the counts view. Whoops. And take that one, and then the onCount inserted. So we can kind of tell that these are view actions because they're directly interfacing with a table view. This gives us a pretty good indication that these are things that a view should be doing. Cool. So you should now have a counts view protocol, which has got these three methods. You can build again just to make sure it works. And it does. Great. So next step. We've pulled out our view protocol, but we kind of need something to actually use it. So what we're going to be doing, as I said, we're going to be using the MVP method. So next step is to go to the counts view controller. And up the top, we're going to add a computed var. Now, this is going to look really weird, but bear with me. We're going to create a var, which is of type counts view. And it's going to be counts view optional. And it's just going to return self. So this looks pretty crazy, right? And not particularly useful. But it's going to become useful, I promise. In the meantime, whilst that's just kind of hanging out, we're going to create a new file, which is, it is going to become useful right now. Head back down to the GetCounts call, which should be on line 95. So we're calling onCounts updated directly here. But actually, we're going to make it do onCountsSelected.CountsView.onCountsUpdated. The reason for this is that basically we don't want to move everything into our presenter before we're ensuring that it's going to work. So we're just making sure now it can't use anything that isn't within the counts view protocol, which is kind of useful, especially when you're working in a really big code base. So next step is to create our presenter. So new file, Swift file, and then we call it countsPresenter.Swift. Again, this time we're just going to make a really simple class, which is countsPresenter. And for now, just make an initializer, which takes a counts view, but don't do anything with it just yet. And we'll talk a bit about why we're doing that in a second. Is everyone, give me a wave if you're there. Awesome. Cool. So head back now to the counts view controller, and we're going to create a property of the presenter. And we're going to use a lazy, because we are lazy too. And it means that we can pass self into it. So private lazy var presenter equals counts presenter. And it's going to need a counts view, which is self. Oh, something's gone wrong. Ah, there we go. So build and run. So yeah, obviously we probably may not want our view controller to initialize our presenter. We may want that somewhere else, but we're kind of assuming we're in the case of a really horrible code base. So we're going to want to move slowly, because you move fast in a code base, you break things. Maybe that's what Facebook meant. But now we're going to have to break a lot of stuff, and we're going to have to break it at the same time. And I apologize for this, but I will explain how you could get around that in just a second. So we're going to want to move all of the kind of model and presenter logic out of this view controller into the presenter we've just created. And the reason we've got the presenter there now, and we've set up the view first, is that it's going to be less work for us to get it compiling. So if you head towards the bottom of this view controller, there is this function GetCounts. We're going to do a good old cut and paste. So get the GetCounts function, the counts function below it, the increment, and the insert, and highlight them all for me. So this is going to be from line 134 to line 208. And we're just going to cut it. And then we're just going to dump that in the presenter right now, because this is kind of the logic that shouldn't really be in our view controller. It's interfacing with core data. View controller shouldn't really be interfacing with core data, especially if it's a 3,000 line long one. So we're going to have some compile errors here, mostly having like unresolved dependencies. So just head back now to the counts view controller, where we will just pick up the dependencies that are at the top of this class. So 54 and 55, which are the scheduler and the persistent container. Head back into the presenter, and we'll dump them there, right at the top. And then in the counts view controller, we set up these two properties just before the GetCounts. So I just want you to take these two, and we're going to cut them again and paste them into the initializer of the presenter. Did I manage to, there we go. That's where my thingy went. So we now have the initializer where we set up our dependencies. This would be very useful if you're going to move towards dependency injection in the future, because we at least now have them in the initializer, so we could push them up to be initialized elsewhere if we need to. We're going to need to fix a compile error here because we need to import core data. So yeah, it was kind of disgusting that we had to cut and paste a lot of stuff. If you want to do that automatically, you either have to use Objective-C and use AppCode, where it does this automatically for you, or, shock horror, become an Android developer, because Android Studio does all of this automatically for you as well. Unfortunately, Xcode does not. So this is why we're resorting to good old cut and paste. Cool. So we'll now have last step is to head back into the counts view controller. And now, because we've moved these methods into the presenter, for example, the GetCounts and Insert, we just want to call presenter.getCounts. And then that will compile. Likewise, increment, presenter.increment. And likewise, presenter.insert. And now, if we've managed to copy and paste everything correctly, we can Command B, and it should run. And I'm really hoping it does. Yes. OK, great. So we've managed to do our refactor manually and keep it working. One thing I want to point out here. So remember, we had the implicitly unwrapped optionals when we initialized them in the view.didLoad. Now, optionals, this is something we're going to come back to in the last part. Optionals are a really good indicator that, or implicitly unwrapped optionals in particular, are a really good indicator that two parts of your code have got different life cycles. So your view controller has got a different life cycle to all of the other stuff that's in it. So, and how can we tell this? Well, let's go to the counts presenter now, and we can actually get rid of these implicitly unwrapped optionals, because now they can just be lets. And this gives us a good indication that now these two properties, the scheduler and the persistent container, have got the same life cycle as the class that they're in. So if you ever see an implicitly unwrapped optional, it's kind of saying, because an implicitly unwrapped optional is saying something's going to be here in the future, but it kind of doesn't really say when that future is going to be. And this is something we'll come back to in part 3, where we're going to look at where normal optionals are a problem. And that is actually it for demo 1. There is a little bit more in the paper, which you don't have paper, but we won't get to that right now, and I'll explain a little bit in just a second where we go from demo 1 to demo 2. This part, we've got our code now. Like I said, we've made kind of minimal changes to the actual behavior. We've just kind of moved stuff around. And we did this to prevent ourselves causing any errors. Well, we can make ourselves not cause any errors by testing our code, which is what we're going to do now. So some tips for preparing easy-to-test code. You want to separate your logic from your view, and also you want to separate the logic from the view lifecycle. because if your logic is tied in with, say, a view controller lifecycle, then you have to kind of call methods like view.did_load or view will appear in your tests, rather than calling it in terms of what we want to do, which is we start to present our counts. Make your dependencies obvious, because then that makes your tests easier. And yeah, like I said, we don't have to pretend to be the view controller. We don't have to be kind of the, what some people will refer to as the puppet master, where we're kind of pulling the strings of an Apple framework. This is a little risky. So why do we write tests? Well, many reasons. They allow us to be sure that the code is doing what it should be doing, rather than something else entirely. And it gives us confidence that when we refactor, we haven't broken anything. And it gives us earlier and more reliable feedback, because realistically, if we have a bug and a user finds out about it, that could have been captured in a test that we would have found out before it even got into a user's hand. So this is the main reason for writing tests. But writing tests is not that easy. Hopefully you had a bit of practice in Mike Katz's earlier, and Andy's got one tomorrow on TDD. So I encourage you, if you've not had much go with testing, to go to Andy's session tomorrow. But particularly when we have like really legacy code, that's really hard to test. And also code relying on external factors such as network or file system, because, for example, if a test relies on the network, then I have to be connected to the internet for those tests to run. And tests that are unreliable, such as the network ones where I can't run them whilst I'm offline, these will eventually get ignored. I'm sure any of you, or some of you at least, have tests that you've commented out because they're a little flaky. As soon as you comment that out, that test is useless. It's not going to give you any feedback. It's not going to tell you when it's broken. And also, good test names are important, because we want to, when we do get that failure, we kind of want at least an indication from the test name as to why it failed. So we're going to be writing kind of pretty large tests today, because realistically our legacy code is not units, so we can't therefore write a unit test around it, because it's a big lump. So we're going to start with kind of a test of like, when a user does this action, I expect the user to be able to see this result. And that's why we split apart the view first, because this gives us a kind of surface to do our testing on. And this means that we can mock this view in our tests, and then that is going to be how our tests work. And with that, we're going to write some tests. Only 2, I promise. And we'll talk about the differences between them there. Just a note, please do start with demo 2 starter, as we have made, or I have made, a few little changes in between the 2 projects, which is essentially when we refactored this presenter and view apart, we were, yes, this is demo 2, we were still using the completion handlers. And basically between demo 1 final and demo 2 starter, we removed those completion handlers and we're using the view directly in the presenter, which makes it kind of a bit more like MVP rather than MVP and this other bit tacked onto it. So, without further ado, we are going to create some tests for the presenter. So, I want you to open the counts presenter tests.swift class. You can find it in the counts test group. And it's very big. So I'll scroll down. Has a couple of commented out stuff that we'll use very shortly. And here is our main test case. What we're going to do is our first test is we're going to be putting some tests around the insertion. So we're going to do func and then test inserting a count. Will return an update with 1 more item. So it's a pretty long name, right? But it's pretty obvious if this test fails, it's pretty obvious what failed, because we can see it by the name. So if this test failed, when we've inserted one, it does not have 1 more item. And then we can dig into the whys a bit later. So just as a note, it has to have the word test at the start, because that's how Xcode picks it up. Just does a regex like the best of us. OK, so we're going to write our test now. What's probably easiest is if you first head down to the bottom of the file, we have this mock counts view. Just uncomment that, because we're going to be using it. So this is going to act as our pretend view. So when we do something with the presenter, this is going to be the pretend thing that we're going to check stuff has happened with it. We're going to have to use expectations because this stuff is asynchronous. There is another way of doing this. If anyone can figure it out at the end of the talk, come talk to me and I will be happy. There is no prize, unfortunately. But yeah, so there would be another way to do this without relying on expectations. Cool. So we're going to write this test now. So test inserting account will return an update with one more item. How are we going to set it up? First, we're going to need an expectation. So I'm going to call it increment expectation. You may want to call it the same. And it's quite hard to see the autocomplete with so big things. So it's this expectation with a description method. And actually, this description is, it should be what a description of if it failed kind of thing. So this will be, the description will be increment callback was not triggered. So it will show this description when it fails to do this expectation. We're going to need a mock view, which will take that expectation. So there, and then it's going to take the increment expectation. And once we've written this test, I'll just show you exactly how the mock view works. And we're going to need our presenter because this is the thing that is being tested. Some people may prefer to put SUT or system under test. I tend not to do that just because I don't really see the point. So we're just going to call it what it is, which is a presenter. So this is our setup. And if you're ever struggling to figure out how to write a test, it's always good to try and split it into given, when, then. So given I do something, when something happens, then I see this. So we're going to split it up. So this is our given. Given I've got a presenter. Now we're going to have our when, which is when I insert an, when I insert an item. So presenter dot insert an account, which is, I apologize, it's a very long kind of data structure. So when we insert a presenter, it doesn't have an ID because it's only got an ID once it's been saved. That sounds kind of funky, right? We'll come back to that in part 3. So ID is nil. Title is whatever your heart wishes it to be. I'm going to call it coffee. Or at least try to. Count is what it starts with, so 0. The total is going to be 3. The interval can be .weekly. Again, the reset time before it's saved, it's not going to have a reset time, so just put nil for that. And increment will be 1. And actually, we kind of don't care about any of this right now, but we just kind of have to do it. So now this is our then. So given we've got a presenter. It's kind of a bit of a lame given, but never mind. When we insert a count, then we need to do our assertion. First, we need to wait, because we've got a expectation. So wait for, and then this is an array of expectations, but we only have one. So wait for increment expectation. Going to give it a timeout of 1 second. And then we've got our then, which is we want to assert that there is one more item. Excuse me, so that's xct assert equal. And then this is a little bit long, but we have mock view dot insertion update, which is an optional dot counts dot count because that's an array. And I will try and keep it on one screen so you can see it all. There we go. Nearly. There we go. And then mock view dot initial counts dot count plus 1. So that should now be compiling. Okay, So yeah, this is pretty much doing what the test says it's doing. So when we have the update of the insertion, it has one more count than the initial counts. Yeah. So if we head back down to the counts, the mock counts view, we can kind of see how it works. The initial counts are saved when we have that onCount updated, which if you remember is when it first loads the counts. And then the insertion update is kind of saved as a property when the count is inserted, which then fulfills the expectation. So we can now head back up to this test, and we can run it by pressing the diamond next to it. But I can't run it on my phone, so pick a simulator. So click the diamond. I hope that that's just one of those random build errors that Xcode gives you every so often, which it is. Yes. So if you try adding that before the insertion, every time I've done a run-through, I've forgotten one of the lines, but it's been different every time. So thank you very much for spotting that for me. So now you should have a passing test. Great. But how do we know this is testing the right thing? If we're doing TDD, we start with a test that fails, and then we make it pass. But here we've had a test that always passes. So how do we know it's actually checking the right thing? Because remember, or if you're not aware, if Xcode kind of has a test pass by default, which is kind of weird. Basically, no other testing framework does this. But we're going to want to be making sure that we're actually testing the right thing. So to make sure that this test breaks when it should, we're going to break the real production code. Don't be scared, we'll undo it afterwards. So what's the easiest way to kind of break the whole kind of thing of this test? Well, we probably want to break something in this insertion method. So if you head down to the counts presenter and head to the insertion method, which is at the bottom. So the easiest way to prevent the insert from happening is to comment out these two lines where it saves it to core data. So if you comment those two out, you can do a command and slash to do so. And then we want to head back into our test. So if the test now still passes, we've got a good indication that the test is not correct, because it's testing the wrong thing. If the test now fails, it's great, because now that's given us a safety net where we could refactor this increment method and know that it's going to break, which is great. So we now have beautifully written 2 is not equal to 3. And so we're just going to uncomment those lines, because we do actually kind of want this to work eventually. We're pretending this is a real app after all. So just head back into the presenter and uncomment those 2 lines again. And we'll just run the test one more time just to make sure. By heading back to the counts presenter tests, we'll just run it again. Cool. So is everyone at the point where they've got the test still passing? Perfect. Great. But actually, this test is pretty lame. It's not that great. Because we've said, OK, when we insert an item, there's one more item. I mean, that item could be anything right now. We don't have any test around what that item is. So this is also a bit of a risk. So this is a pretty weak test. We would call it a weak test. We can make a stronger test, which actually kind of tests some stuff on that item that was inserted, which is what we're going to do now. And because we're somewhat lazy developers, we're going to copy and paste this test. So just copy this. And paste it here. And this time, we're going to call this one, we get a compile error because that's called the same. We're going to call it test inserting account. We'll get rid of this bit. It will return an item with the same title. So probably no surprises about what we're going to be asserting on this test. It's going to be the title. To do that, we're going to need to change our expectation. So just delete that. And in the meantime, uncomment this extension that we've got here on incremental update. This is just a little test helper, which is just going to pick out the first count that was updated, which just makes essentially less work for us and makes the test less big. So now we're going to do xet assert equal. And this one, again, it's a bit of a long one. But mock view dot insertion update, which is an optional. First updated count dot title. So I will try and get that to be the full screen again so you can see it. There we go. And then this is going to be count request dot title. Now we don't have the count request right now, but it kind of looks somewhat similar to the count that or it's a pretty good indication that it's probably going to be this count here, because this is the count that we're inserting. So just before here, we can just save that as a property, a variable. Let count present, oh no, that's completely wrong. Let count request equal, and then we can take what we've got in the insertion, the line, maybe line 55 for you. And we're just going to want to take that count, and we're just going to paste this. So this is just cutting and pasting what we had before. We've just saved it as a variable so we can use it in the assertion. And then we want to insert that count request. I mean, we could really run this one test by itself, but we're going to be good developers and we're going to make sure we run all of our tests together. So you can do this using Command U or by just ticking the diamond at the top of the class here. Cool. This passes. Again, no surprises. This code has existed before this test, therefore it would pass. And this test is just asserting the titles. So, again, we're going to make sure that we break this test in a way that it should be broken in order to make sure that the test is actually correct. We're not just testing something completely random. So with that, we'll head now back into the counts presenter. And because we're asserting on the title, we're going to change the title. So on line 103, where we set the stored count.title, can just comment that for now and just put something else in its place. So for example, I'm going to be meet new people at RWDevCon. Whilst it's a very great count to have, it's not correct right now. Not that I don't want to meet you all. So if we run this, the first test should still pass, and the second test should now fail, because the title is not what we expect it to be. Cool? Does everyone else have the same? Everyone got failing tests? Great. I mean, not great. You never want a failing test, but cool. So with that, we will head back to the presenter. And we will actually make this be correct again. Then we'll run the tests just one more time, just to make sure we haven't broken anything. Now, obviously, this is still a really small code base. Oh, God, I thought it failed again then. Yeah, this is a small code base, so we're being really overly careful for this code base. But in the case that this is kind of 500-line presenter, you probably want to tread carefully because it's pretty easy to break stuff. And actually, that is it for demo 2. Cool. So, hi again. Welcome back. Hope you had a great 10 minutes. Cool. So, part 3, we're going to be looking at not repeating the past. You know, in an ideal world, we would have had 8 hours of kind of refactoring everything, and it would have been perfect. I'm sure you all would have loved that. But realistically, we only had the last 2 quick demos. So kind of imagine that we've now got ourselves into a really great space. Everything is tested. Everything is split apart. How do we prevent that from kind of collapsing? Again, I can't remember if it was in Anthony's or Mike's talk. One of them was kind of saying that it takes a lot of work to prevent your structure from degrading again. And we're going to look at some techniques around that. And this is where we're going to come back to the code smells that we talked about earlier, and I'll just introduce you to a couple of those. So, yeah, realistically, very rarely it's the computer causing the bug, it's the developer. I'm sorry, it's a hard fact to learn, but it is our fault normally. Yeah. So testing makes it easier for us to, I'm going to stand. Testing it makes it easier for us to find out when we've made a mistake, but the mistake has already happened by that point. So we can kind of make our coding a little stricter, and this will allow us to find the mistake before we've even run the test, and because we can use the compiler to our advantage to make the compiler prevent us from doing stuff that we shouldn't be doing. So I'm going to call this term offensive coding. If anyone's heard the term defensive coding, it is essentially making sure that you handle all eventualities. Offensive coding is making people not let you have to handle those. So we have this beautiful diagram here that I really quickly threw together. The kind of treasure in the middle is our app. And this is kind of what we want to protect from the outside world. We want to protect it from the scary ghosts. We want to protect it from the rather pretty-looking skeletons. But we also want to protect it from the cute dogs. Because in this case, the cute dog is not our own dog. So the cute dog may be nice now, but it could be evil in a few years. So we want to keep ourselves protected kind of from external things, because this makes our code less dependent on other things and less likely to break. So yeah, the best defense is a good defense. If we don't want to let something happen, then we make sure it can't happen. So one way of doing this is strong types. So strong types are probably a pretty familiar thing to you. So the benefit of a strong type versus weak typing, for example, JavaScript, is that if you do something wrong in JavaScript, you only find out about it when you run it. Whereas with strong typing, we have the compiler in the middle, so we find out about it when we do the compiling, which is a lot quicker. And also, with the problem with like a runtime crash, is we could never actually cause that crash. We may never find out about it, and actually maybe a user finds out about it 2 months later, and then you get an angry 1-star review on the App Store. So by making sure that a runtime crash is actually a compile time error, we find out about that so much quicker, and we guarantee that we find it. Strong types, we can compare, probably the best comparison is URL and string. So you can store a URL as a string, but there's kind of a load of different features you don't get if you keep your URLs as strings. For example, you don't get validation. You know that the URL string initializer is failable, so it can return an optional. That's because it does validation for you. So if I have a URL Swift object, I know that it's a valid URL. Whereas if I keep that as a string, it could be anything. And then we have to guard against that being anything, which is not great. And we can also use data objects like this to link together related concepts. So for example, on the URL object, there's a lot more information. For example, you can get out the host, or you can get out the path or the query fragments, which you can't do on a string. And we want to make sure our modeling is good. So this is something that I see a huge amount of, particularly from leftover old Objective-C code where this wasn't really a thing. In Swift, it's a lot better, but we can still always improve. So by modeling your code well, and what I mean by this is, for example, our counts model. By modeling that well, we get a huge amount of information just from the compiler. So if I have an object which is completely mutable, how do I know when, but it comes from the API, that API isn't actually mutable, because an API is just a one-way street. And likewise, if I have everything optional in a model, how do I know when that model is valid? If model has an optional ID, does it make sense that this thing is, does it make sense that it doesn't have an ID? Probably not, because then it's probably not valid. And essentially, yeah, the less code that can happen, then the better. So we're forcing people to do validation. And so technical debt is basically a big killer of apps. This is kind of the thing of your app gets so hard to work with, and then it just becomes impossible to work with. And this is kind of the tech debt that is built up. You can find so much information about this. We have to remember to improve our code, but we also have to remember to clean up after ourselves. Because if we have code that doesn't work anymore, or is not valid, or just is never actually used, then that's more code for somebody to understand. And the more code there is for someone to understand, the more questions they have to ask themselves. Particularly if you've ever had kind of a bug and you try to put a breakpoint in these kind of 3-4 spaces, and you actually find out that 2 of them are never called because they were left over from 2 years ago, then this is kind of the problem. So you should always clean up after yourself. This is called the scout rule. It basically says always leave the code cleaner than you found it. And by using this, you can prevent yourself getting down into this kind of technical debt hell. And it also makes less work for your team. So with that, we're going to go into demo 3. We're going to look at a couple of code smells that we've come across, and also one that we haven't come across, but will actually make our lives a lot easier in the future. So you can start from demo 3 starter, or from what you currently had at the end of demo 2. So the first thing we want to do, so we kind of talked a lot about modeling, and the only model we really have here is count. So we can kind of take a look at it. So if you open the count.swift file, it's relatively basic. But remember earlier we said, OK, this ID is a bit weird. It's optional. And the reset time is optional. That's a bit weird. We'll come back to that in just a second. So when we talked about using strong types, we've got an ID here, which is a string. Now, that could be anything. And actually, we won't do any validation on this. But if you imagine the case, so if this is a bug I've seen many times before. So we have a count, and we have a list of counts. And then we want to go to the detail page. The way we're going to probably do that is we're going to pass the ID from one view controller to the next. Now, if this ID is a string, we could actually mess up. We could pass the title instead in that case. And then we're going to get an error. And that's kind of something that we shouldn't be allowed to do. That should be forbidden. So we're going to use a data model in order with the ID in order to prevent that kind of thing from happening in the first place. Fortunately, we don't actually have that in the app because it's really bare bones. But this is a really useful thing, especially when passing stuff between view controllers. Make sure it's not a primitive type. So we're going to make a struct here, whoops, which is called ID, and it's going to conform to equatable. Because if you kind of think about it, an ID should be equatable because we should be able to compare 2 IDs from each other. And actually, it's just going to have a single property, which is raw value of type string. So you see, we're still kind of using the string, but we've put a wrapper around it, which will ensure that we get compile errors kind of where we expect them to be. You can click the little kind of stop sign to add the stubs for us, because I can never get it right. So that should add you a static function. And then actually, I mean, we just have this raw value. So we can just return the left-hand side's raw value being equatable to the right-hand side's raw value. So yeah, it kind of doesn't look like it's doing much. But this would actually be really, really useful in a really big project. There's a term called primitive obsession, which is one of the code smells, where you're essentially using strings to represent things that aren't strings. And if you're kind of unconvinced by this, I recommend you go and look that up somewhere. Or talk to me later. That's not just like, it's not my problem. Yeah. So we can now change the ID of the count to be an optional ID. We said that the optional is a bit weird, but we'll come back to that later. Probably going to have a lot of compile errors here. Again, we're not in a position where we can have this stuff done automatically for us with Xcode. So we're just going to have to do it ourselves. So you should have 4 build errors. We're just going to go through them down one by one. So the first one is in countspresenter.swift. And it should be in the private counts function. This is simply where we did have a string. You can see it's coming from core data, and we just get the absolute string of the URI, which is already kind of an indication because that this is a bit nasty, because we're kind of just, again, we've got a URI, which is a URL, and we're just saying, I don't care about the URL, just give me the string, which is never a good thing. So this we just want to replace with initializing account ID with a raw value, and it's just going to be raw ID. So it's pretty simple. This is just going to be a wrapper, and it just kind of essentially makes it easier to not mess up. The next one is going to be in the increment method of the counts presenter. And we're trying to create a URL from a string, but this is no longer a string. This one's really easy, just do dot raw value. Now this next one, this is in our incremental update object. So what we have to do is we will go to the counts view controller where some very irresponsible person dumped it. It should probably be in its own file. But I needed to make the code look really long. We want to change this updated thing because it's currently a string. Again, this could be anything. We're kind of relying on this pretty heavily. So we're going to make this an array of count.id, and this updated method is going to take count.id. Okay, yeah, so like I said, had we all been Android developers, this would have been able to be performed automatically for us. Now I'm realizing I should have just done this as an Android talk, but there's always next year. So if we build and run, we have one more compile issue, which should be, if you build, you'll get another one, which is in counts presenter. We can just click it, and again, we need to convert between our string to our new ID object. And now, once you've done this one, so this is in the insert method if you manage to get lost. Cool. So, should be building. Yeah, so this is still kind of not great. Right now, I didn't really get the chance to figure out a better way of this. Because, for example, right now, this ID is very tightly linked to core data. This is not something we really want to keep because we would ideally want to be able to swap out core data for another type of persistence, for example, realm. So right now, a string is kind of convenient because it can take everything, but that doesn't necessarily make it the best code ever. Cool. Let's now head back to that problem of the optionals I was talking about. So we're going to head into the count.swift, just to have a look. We're not going to write anything in here. But like I've kind of been saying along this talk, the ID is optional. And I know that the ID is nil when we haven't saved an item yet. And once we've saved an item into core data, that item is not nil. But that's implicit knowledge. I know that, but you may not necessarily know that. And you've just come to this code base. And I want to make this as easy for you as possible. So kind of having this optional is, again, it's a code smell that this count struct is actually kind of representing two different states of object. Now, if you think about it, no, I'm not going to do that because that's going to spoil it. But I will come just back to that thought in just a second. So we kind of, there's some other data model here. We're not quite sure what it is yet. So we're just going to kind of be a bit reckless about it. So we're going to create a new file, which is a Swift file. Now, like I said, we kind of, by the optionals being there, and them only being filled in certain states, that gives us an indication that there's two states being represented by one object. I don't quite know what that other object is right now, so I'm just going to call this foo.swift. Because realistically, I don't know what it's called. Once I start filling in the gaps, we're probably going to get a good idea of what it is. So create a foo.swift or whatever random name you would like it to be, and create it. And we're going to create a struct, which is foo. It's a data object, and we're in a pure Swift project, so we should probably be using structs. And again, we've just called it struct foo. I still don't really understand what its role is, but I'm going to try and create it, and then I'm going to get the name from it afterwards. So if you've got to that point, now we will head back into the count.swift, and we're going to copy all of the properties from it, because like I said, there's two data models in here. We're going to copy all of these, so copy them, and then we're just going to paste them into our foo struct. Oh, I always miss the line. There we go. So, just fix this compile error in interval and just name it count.interval. That's all you need to do there. We still have a compile error in ID, but like we said, there's two states here, so the states are going to be there is an ID and there's not an ID. So we're going to delete this. And we're going to delete the reset time as well, because actually these two are both set at the same time once it's stored into core data. So this is what your foo struct should look like. So we kind of have everything that we want to store in core data, and then in the count stuff, we've got everything that we pull out of core data. So to me, this kind of seems kind of like a request response kind of pattern. Like for a URL, you don't use the same data object to represent the request of a URL and the response. You have two separate objects. So I'm going to call this count request, because this is what I'm asking our persistence layer to save, and then we're actually going to get the real value back from it. So I'm going to try Xcode's refactoring rename tool. It has not yet worked in any of the run-throughs. So fingers crossed, and it didn't work. Thankfully, it's only 3 characters, so you can just highlight this one. If you're feeling brave, you can try it too, with the rename. But we're going to call this count request, because now we've got an indication of what this object's role is. So we now have this kind of request, which is before it's saved to core data, and then we use the actual count after core data. Now, obviously this is a small project, but we're pretending it's a big one. We don't want this change to happen all at once. So what we're going to do is, this is also going to look a bit weird, but it's kind of very useful to prevent your changes from splatting all the way across your code base all in one go. So create a computed var, which is called AddCount. And this returns a count. So remember, this is the old model. So this is going to return basically what the old model would have had in this case. So like we said, before we saved something to core data, it's got a nil ID. So that's going to be nil. The title is going to hopefully not change. So that's just the title of the request itself. Again, count is going to be count. Total is going to be total. Interval is going to be interval. Reset time is going to be nil, because again, we don't get reset time until we save it to core data. And increment is just going to be increment. So hopefully you now have this. And this is we're going to iteratively introduce this into the code base to prevent everything from breaking all at once. Like we said at the start, we don't want to be non-compiling all of the time. Or sorry, as little time as we should. So we can either start from kind of the bottom going up or the top going down in terms of from the user interaction or from the database. We're going to start from the user interaction. Don't know which way that is. Kind of immaterial. So if we now head into the AddCount view, this is essentially the orange little bar that you saw at the top, which allows you to type in some text and add this as a count. In the method, text field did end editing, which is in the extension. No, that's completely the wrong one, sorry. Text field should return, still in the extension. At least I got that bit right. Yeah, we have our kind of, this is where we create that object that we're going to save. Kind of a good indication that we've got the name right is we've already called the property request. How convenient. It's not like I planned that one at all. So we'll replace this as a count. So it was a count, sorry. It's now a count request, which means we need to remove the ID because it no longer exists. and also the reset time. So great. We've just made our new object, but that kind of sucks because this delegate requires a count. Well, no problem. We want to move slowly, which is why we have that .AsCount. So we can still convert between the two models. We can convert between our new shiny model and our old rubbish model. And this is really powerful, especially when you want a really big code base. So in an ideal world, we would now run our tests and commit. We're running out of time, so we're going to be cowboys. So what we would need to do now is we would head up to this delegate, which is at the top of this method, at this file. Oops, too far. And where we have AddCount view did finish creating count. This is now going to be a count request. And this is going to cause a compile error further down, where we did that AddCount. So just head back to that, which is in text field should return. And we can now just get rid of that AsCount because it actually now expects a count request. So this is great. We've managed to introduce this iteratively. We first kept it just inside this class, and now we're exposing it to the delegate. Unfortunately, this one's going to give us a compile error. You could always use kind of optional deprecation. You could deprecate the method, but for time, we won't do that this time. So now we have counts view controller does not conform to protocol add count view delegate, as you may be able to see in that mush on the top left. So this is the delegate that adds count view, which we can find on around line 104. So this still has the count, but we can make this count request. But likewise, we can still limit this. We don't want to break the presenter right now because we're not compiling. We don't want to stay compiling not compiling much longer. So again, we will just do AsCount. And then now we would commit, we would run our tests. And now this time, we will go into the presenter and make the presenter take a count request. So this is in insert. Again, good indication we got the name right. That's what it was already called. So we change the insert method to have the count request. And this is great. And it's a really good indication that we've got this model correct, because the two items that were there, which we removed, the ID and the reset time, weren't actually used anyway. So this is a really good indication that we have correctly split apart two models. Running a little low on time, but is there like buffer time at the end? Yeah, that's absolutely fine. Cool. So, but like we said, we've added some strong types. We've improved our domain modeling. Now we need to go and clear up our mess. So this time, we need to head back down into the count Swift. So now that this object is no longer representing two states, it's representing just one. So we will make this the ID and the reset time non-optional now. And now we don't have to ask ourselves that question of when is the ID optional and when the reset time optional, because it's not optional. So we know that we have a valid count when it's got all of these items. This is going to cause us some build errors because obviously we have gone something that is optional to not optional. So just what I tend to do is just do a build and then find the errors afterwards. So we have an error in the count presenter increment method because we're trying to check for an optional that is no longer optional. So we can just rewrite that here. And we can get rid of it out of the guard. So build, we still have one final error, which is in this AsCounts method. Because we've iteratively done this, we don't actually need this anymore. We can just delete it. So the main app is building. the tests are now failing. The tests will fail to build. So we can just head into the tests. And we change, yep, because it should no longer have a nil. So we just make this a count request. Again, we get rid of the ID, which is nil. And the reset time. Same for this test. Get rid of the ID. And get rid of the reset time. Did I get rid of? No, and change this to a count request. Cool. So now, we've made a big refactor now. We should run our tests to make sure they still pass, which, fingers crossed, they will. And then by this, we know that we've kind of cleaned up our mess, and we've made there less stuff for developers to have to question. It's a lot more obvious now. We can document the count request. We can say when a count request is used, but we don't have to ask ourselves specifically when is the count ID not valid. It says it's testing. Yes, great. It was just taking its time. So we have our test passing. So we haven't broken anything, at least in the context of these two tests. We would ideally have way more tests in this case. So that's it for demo 3, where we've done the 3 bits that we said we were going to do, and we've kind of made ourselves offensive coders now. So with that, let's sum up what we've done today. It's been a pretty whistle-stop tour, and it's obviously in a very tightly limited code base, which is kind of quite easy to work with anyway. Hopefully you will be able to practice this and apply it to larger code bases, such as the ones that you probably work on. So what did we learn? So from demo 1, we refactored to get to a better state. Demo 2, we were testing our code to give us safety of further refactors. In demo 3, we were strengthening the constraints in our code in order to prevent people doing the wrong things. So how did we do this refactor? Well, we extracted methods, because this splits the actions from the results, because one object should not deal with an action and a result. We pushed logic into a presenter, and then with further refactors, we could push that into our model object, for example, a repository or something, because we wouldn't really want that core data stuff in the presenter. And the way you can tell if you've got that separation really good is at the end of this, we no longer need an import of core data in the view controller. So we've moved all of that model logic out. And ideally, we would not have the import of core data in the presenter, because we would have moved all of that out into somewhere else. And then this makes us a little more confident that the view controller doesn't rely on core data, which then gives us confidence to swap out core data in the future for something else, such as well. We made the view controller implement the view protocol simply because it was the biggest thing, and it's good. And yeah, we use MVP here, but I want to be really obvious. Any architecture is good, but any architecture can be bad when it's done badly. So, for example, a lot of things that I find is people think that massive view controllers come from MVC architecture. They don't. They just come from no architecture whatsoever. So MVC itself can actually be quite good. It's pretty similar to MVP. That's why there's only one letter difference. Yeah, so just kind of be careful, know your architecture, and be confident enough to make sure that using the architecture won't make it worse. So in demo 2, we tested our code to give us safety. We didn't actually do the be careful of unintended test actions, but I think that's in the documents, which you can read. And we also think of how strong we want our test to be. The stronger the test, the harder it is to change. But the weaker the test, the less confidence we have that it's actually going to catch something. So we could have a test that tests the title and the increment and the count and the total, but then it becomes harder to change that object itself. So it's a trade-off depending on how you want to test and where your risk level is. But especially in an old code base, you want your risk level to be relatively low. You don't want to take any risks. So this is using strong tests. In demo 3, so we kind of looked at the fact that the most flexible code is not always the best. So code that's doing more than one thing should not be. So splitting up our data models, by using optionals, because they show us greedy objects. They show us objects which are doing more than one thing. So you can use optionals and also the compiler itself to your advantage. You can use it to indicate problems with your modeling or problems with your life cycles, such as we saw in demo 1, where we had the implicitly unmapped optionals. And it's actually, yeah, it's a really powerful thing. Never make something optional that doesn't need to be, basically. You know, I see a lot of things where people use optionals because it's easier to initialize an object, but actually it's more lines to do it with optionals than not. So in terms of where to go from here, so if you were either Anthony's or the architecting modules one this morning, they had some really good resources as well. These are the ones that I would recommend. So Growing Object-Oriented Software by Steve Freeman and Nat Weiss. This is a really good intro to kind of refactoring and things like this. Clean Code is one of the Clean Coder series by Bob Martin. If you're more of a website person, don't like reading books, there's this really excellent website I found recently called Source Making, which will tell you everything about a code smell and the underlying problem it actually indicates and how to then fix it as well. You can find me on Twitter and Medium at the same place where I normally talk about things like code smells and, again, like what the code smell is actually the underlying problem and how to fix it. And that's it. So thanks very much for coming, and enjoy the rest of your RWDevCon.